This next case study is based on the same site that we were looking at, different time frame, but this time the operator wanted to understand emission events related to BTEX coil operation after reviewing emission data of that associated area in the southeast corner of their facility. So again, we have our fence line sensors. They suspected that the site might require a new combustor system to handle the BTEX gas that wasn't being burned by the reboiler. So in the bottom here, we have our 1-day rolling rate of that area there. So our continuous monitoring devices detected elevated emission levels during periods when the BTEX system was on and the reboiler was burning BTEX gas. Operators analyze these emission patterns while testing different control valve configurations on the BTEX system. Initially, the working assumption was that the system was generating more BTEX gas than the reboiler required or could even process, overwhelming the system and thus requiring the purchase and installation of an additional combustor. But having the real-time emissions data helped them narrow the investigation to actually uncover the real issue of a leaking PSV on the BTEX coils themselves that needed to be replaced. So once the PSV was replaced, emissions data trended back down. So we can see here we have our monthly data. This is your 7-day rolling average, and mid-month, things really start to trend down when they made those repairs. Now, this is a strong example of how continuous monitoring data supports better capital planning decisions. Instead of proceeding with an expensive equipment purchase, the operator used this real-time emissions data to first test their hypothesis, next evaluate their system behavior, identify the actual root cause, and avoid unnecessary capital expenses, which gave them improved confidence in their operational decisions.